All right, we're going to finish up section 1.5 today, hopefully. Yes. You got to fill out in your book where you're going, what time it is, and I'll sign it. All right, so we are doing section 1.5 again. I'll just write it here instead of type it out. So we're doing section 1.5. I believe this is part C. Really doesn't matter what we call it, but I think it's the third time that we've taught lesson 1.5. I think. All right, so let's do this. Let's talk about angles. We already talked about angle. We talked about the definition of an angle, right? So if I had two rays with a common endpoint, do you remember that? There's the common endpoint. There's two rays. We've got an angle, all right? So we know what an angle is. We know how to label an angle, to name an angle. So if I had 3 points, if I had A, B, and C, there's a couple ways I could, you don't have your agenda book? You got to get one. You didn't write where you're going. Write where you're going and all that stuff. I don't need to write all that. And what time it is and the date. All right, so you've got this angle, and we could call it what? We could just call it angle B if we wanted to, because there's no other angles coming out of here. What else could we call this angle? Ethan? Right, we can call it angle ABC. So make sure you put the angle symbol in front of it. All right, I've had people write this, angle ABC. Okay, is that the way we're supposed to write it? No, we're supposed to write it with the symbol. We're supposed to write it with the symbol. So don't write the word angle. Don't just put ABC, but put the angle in front of it and then ABC. Or you could call it angle B, or another way you could call it would be what? There's only one other way you could call this angle. CBA, angle CBA. Yep. So it doesn't matter which one of those. But today what we're going to do is we're going to do some special angles, okay? Some kind of specific angles. So we'll call them special angles. All right, here's the first one. Let me do this before we do the special angles. Let me do one more thing. Like this. Okay, I've got a couple lines. Got a line going here, line going here. And I got some angles in here, don't I? Yeah. All right, because if you wanted to think of it as a ray, right, here's your end point. There's a ray going this way. There's a ray going this way. So, first of all, what if I went all the way around? What if I started here and I went all the way around to here? We measure angles in a thing called degrees, right? And you should probably already know this. If you went all the way around a circle, how many degrees did you go? 360 degrees, right? 360, I'm sure you've heard that word before. Shouldn't be new to you. 360. But look, I took that whole circle, but I broke it down into how many parts? 4 parts, right? So if I wanted to find out just what this part is, and I broke them up evenly, right? All 4 of these angles are exactly the same because they're straight up and down. We'll give a better word for it later. But I've got 4 parts, 360 degrees out of 4 parts. So how much is each part? 90 degrees, because 360 divided by 4 is what? 90. All right, so this right here would be 90 degrees. This angle right there is 90 degrees. Sometimes we'll do this. We'll put it up here. Okay, we usually call this one that goes to the right. We call it 0 degrees. All right, this is 90 degrees. Tell me what degrees this is going to be from here. Be 180 degrees. Okay, what would this down here be? Very good. Okay, just add 90, right? It's easy to add 90. How do you add 90? Just add 100 and do what? Minus 10, right. Everybody listening? Got a lot of conversations going on. Okay, I should be the only one that I hear. All right, so we've got all that stuff. So that's how we know that that's 90 degrees right here. So with that said, let's get rid of this, and let's do this. So here's an angle, and we have a special name for it. All right, so here's an angle right here. You don't know exactly how many degrees that angle is, but you do know it's between what and what? 0 and 90, right? Or it's less than 90. Would you agree? All right, because if this is horizontal, this would be 0 degrees. If it went straight up like this, that'd be 90 degrees. But it slants in, doesn't it? So it's got to be what? Less than 90 degrees, okay? And we have a special name for it. So if you have an angle that is less than 90 degrees, all right? I mean, it could be like 89.99999 degrees. That's still less than 90 degrees, all right? If it's 0.00001 degree, that's still between 0 and 90. It's still less than 90. Agreed? All right, we have a special name for that. We call that an acute angle. A-C-U-T-E. I'll just put the angle symbol. So that's an acute angle. It's less than 90 degrees. It's pretty easy, isn't it? And we'll refer to that a lot. A lot of times we'll say, like, there'll be some theorems, there'll be some postulates, there'll be some things like that that talk about the acute angle. You need to know what it means to be an acute angle. We'll also talk about this a lot. In fact, I think, I'm not 100% sure, but I think we have a chapter that is just on this type of angle, this next one. All right, so here's the two rays coming out like this. So what does it kind of look like that we just talked about a little bit ago, Matthew?
Right angle.
Looks like a right angle. Now, if I just put this up here like I did, just sitting there right there, do you know 100% that that's a right angle? Why not?
Because it could be 89.99.
Exactly. It could be one of those 89.99999 degree angles, right? You really don't know. Listen, you really don't know that that's a 90 degree angle unless they tell you, all right? If they tell you it's a 90 degree angle, then you're okay assuming, or not assuming, but then you're okay working with it as if it was a 90 degree angle. There's one way that they can, there's several ways they can tell you, but there's one way in particular they can tell you. Do you remember this one? Yeah, you put a little box right here. Little box right there. That right there tells you that this is a right angle. I keep saying right angle. I'm supposed to save that for the end. But anyway, a 90 degree angle is called a right angle. All right, so a right angle is equal to, I'll just put equal 90 degrees. It's exactly equal to 90 degrees. It's not less, it's not more, it's exactly 90 degrees. It's a right angle. Okay? Pretty simple, isn't it? Yeah. But it's important. It's simple, but it's important because we're going to see this kind of stuff later on. It's pretty, we're going to see a lot of it. The 90 degree angle things. Okay, here's another angle. Another special angle. And you probably do. Yeah, you probably learned this in like middle school or something like that, I would guess. Did you learn these things in elementary?
No.
I think some schools probably taught it in elementary. I don't know if we did here or not, but somebody get the door, please. All right, and you've already said it, so I'll just say it. It's an obtuse angle. Can somebody get the door, please? Those who sit closer to the door are responsible for getting the door when somebody knocks on the door.
I didn't hear that. Sorry.
All right, this is called an obtuse angle. So what do you think? What do you think must be true about an obtuse angle?
It's more than
Right, we'll say greater than instead of more. Is that right? So it's greater than 90 degrees. Technically, they say it's between 0 degrees and what do you think? 180 degrees, right. But I'm okay with you just understanding it as greater than 90. All right. Technically, the definition is between 0 and 180, but that's okay. All right. Simple so far, isn't it?
Yeah, what are you gonna say? What did you say? It's no greater than 180.
It's no greater than 180.
Don't say that.
Yeah, that's kind of hard to understand.
Well, no,
Here's another one that you. Everybody, look here.
A line.
It looks like a line, doesn't it?
Yeah.
But I got a point right there.
The midpoint.
So really, well, it's not necessarily midpoint. It doesn't have to be. Because I don't know. I don't know that this is equal to this. Plus the rays. Shh. Everybody ready?
Yeah.
It's so frustrating trying to teach us something, and then I got people turning around and people talking to each other. Because I know it's not getting through your head. All right? And then you're going to ask me questions about it. I've been there a million times. All right? Just watch. Pay attention. Be a student. All right? Just be a student. That's what you're supposed to do. All right. Enough of that. Let's take a look at this. It's not the midpoint. You can only have the midpoint of a segment. Is this a segment? No, it keeps on going. You got arrows in both directions. Okay, so it can't be a midpoint, but it is two rays, isn't it? I've got two rays with a common endpoint. That's what an angle is. So this is an angle. These two rays make up an angle. It doesn't look like an angle. We're not used to seeing this as an angle, but technically it absolutely is an angle. And again, we're going to be using this a lot as well. How many degrees do you think this angle is?
180.
Yeah, from here to here, right? That's your angle right there. Even though you don't think of it as an angle because there's no real bend to it, is there? But there doesn't have to be a bend to it. Okay, an angle is just two rays with a common endpoint. It doesn't say that it has to have like a bend to it. It's the only word I can think of right now, right? But this is 180 degrees. So this is a straight line as well, isn't it? Normally we don't say straight line because in the definition of line is the word straight. So if I say straight line, it's kind of redundant, isn't it? So if I just say line, automatically it's straight, okay? But it is a line, and it is straight, right, because it's a line. So what kind of an angle do you think we're going to call this? Say it. I heard it from somebody who whispered it. Straight angle. We call it a straight angle.
That's odd one.
Okay? Again, it doesn't look like an angle, but now we know it is an angle because two rays with common endpoint means it's an angle, but it's completely straight, so we call it, guess what? A straight angle. And a straight angle is exactly equal to 180 degrees, not less, not more, okay? Everybody good with that?
Yeah.
All right, let's move on. I can't scroll up and down because then I lose my little marker, so I don't write off the edge of the board, so let's do this. Seen this before. I'm going to write it again. But we're going to talk about another word. So I got two lines that intersect each other, but they intersect each other in a particular way. What kind of angles formed right here?
Right.
Yeah? How do you know?
We don't.
You don't know.
Up to.
Well, you can't even tell. It's so close, there's no way to tell, is there? But what if I do this? Put a little box right there. Now what kind of angle is it?
Right.
It's a right angle, okay? You follow me? It was kind of like a trick question a little bit. Because it sure looks 90 degrees, doesn't it?
Yeah.
Yeah. And it technically is because I made sure I hit the shift key, it makes it horizontal. If I go up and down, the shift key makes it vertical. So I know it's 90 degrees. But if they don't label it in the book or on a test or quiz, if it's not labeled as 90 degrees, you cannot make the assumption that it's 90 degrees. Everybody with me on that?
Yeah.
So you cannot just look at that and say, oh yeah, that's 90 degrees, that's a right angle. You can't, unless they tell you. And this is one way that they could tell you. Everybody good?
Mm-hmm.
Here's another way they could tell you. Let's put some points in here. This is C and this is D. This is A and B.
Wait, why'd you not keep...
I still can't tell you that that's a right angle, can I? But if they were right angles, two lines that form a right angle, they have a special word for that. And I'm sure you've heard this word before. It's perpendicular. Have you heard that word before? Yeah, I'm sure you've heard it.
Yeah.
Okay? It's called perpendicular. Perpendicular means when two lines come together to form a right angle. You can write that down if you want. When two lines intersect and form a right angle, okay, then those two lines would be perpendicular. We have a special symbol for perpendicular. The symbol looks like this. Kind of looks like an upside down T. All right, that's the symbol for perpendicular. So what if they said this? What if they said that line AB is perpendicular to line CD? They tell you that. They tell you that that's true about this picture. Even if I don't have that little box right there, what can I now say about this angle right here? That's a right angle, exactly. If they tell you that they're perpendicular to each other, but they have to tell you that, okay? They have to tell you that it's perpendicular. Once they do, then you could say, if these are perpendicular, then you know that that's a right angle. So you could put the little box there if you wanted to, all right, if they told you that they're perpendicular. What if they just put the box there, but they didn't say that they were perpendicular? What if I put the box there? What could I say about those two lines?
They're already angles.
The lines. The lines. Then they are perpendicular. Okay, if I know that it's a right angle, we don't need that. If I know that it's a right angle, then I know the two lines are perpendicular. And the other way is what? Oops. Shoot. Oh, I know what I wanted. Boom, boom. There we go. Let's do this. All right. And if they tell you that they're perpendicular, then what could I say about that angle? Then they're right angles. Then they're right angles. If they're perpendicular, then I could say that it's a right angle. All right. I mean, sure. If they tell me it's perpendicular, then I can tell they're perpendicular, right? I mean, that's goes without saying. But if they tell you it's perpendicular, what can I say about the angle? It's a right angle. Got it? Good.
Got it.
Got a couple more of these to do. Let's draw a couple more angles. I'm going to draw one that looks like this. Good, because we're going to be doing that a lot. We're going to be talking about a lot of angles this year. All right, there's an angle right here. I know you're being sarcastic. Okay, there's an angle. Watch what I do. Let's put a dot right there. What I'm going to do, listen to me, on my program that I use to record all this stuff, I can copy and paste, right? Control-C, Control-V. You ever do that on other, like Word or something like that?
Yeah.
Did you know it was Control-C, Control-V?
Yeah.
Okay. So I just hit Control-C, and now I hit Control-V. Tell me something about these two angles.
They're the same thing.
They're exactly the same thing, aren't they? Because I copied and pasted. Look, I could twist it around.
Come on, guys.
I could even twist it around. Is it the same angle?
Yeah.
Yeah, it's just moved around. I didn't make it wider or skinnier or anything like that. Okay, I just twisted it around. It's just exactly the same angle. All right. Here's a little notation that we use to indicate that they're exactly the same angle. So let's just call this angle 1, and let's call this angle 2. Right? If I did this, watch this. If I did this, if I put a little arc right here. So if I just put one arc here, and then I put one arc right there, that tells me, remember the little tick mark things we did the other day? All right, that tells you that the segments are equal to each other. These little arcs, when I put an arc right there, that tells me that the measure of the angle are equal to each other, are the same. Everybody got that? So what could I say about the measure of angle 1 and the measure of angle 2? That they are...
No. The same thing.
They're the same thing. They're equal to each other. They're the same. So, now I just put the 1 and 2 there. That doesn't mean it's 1 degree and 2 degrees. All right, but what if I said this was, I don't know, 30 degrees? And then I asked you to find what the measurement of this angle right here was. And that's it. That's the only information they give you. So if that one is 30 degrees, what's the other one going to be?
30.
How do you know the other one's going to be 30 degrees as well? Just because it looks like it's the same? Because of the arc. Very good. The little arc right there, ARC. It's not, what do you call that? Learn Resource Center. Was it Academic Resource Center? It's not that ARC. This is what we call this. This is an arc. Okay? So we put a little arc here, and that means they're equal. So if I know, let's call this angle A, and I'll call this angle B. If I know angle A is 30 degrees, and I know these two angles are equal to each other, what's angle B equal to? It's also 30 degrees. Okay? Now, it's not always going to be that easy. Matthew, stop throwing things. Stop throwing things. Okay? You hand it. You don't throw it. I know you're throwing. I know. All right, so that's... oh, by the way,
Oh my gosh.
we call this congruent angles. I don't think I said that. So we say the angles are congruent to each other. Congruent, I'll put it right here, angles. Right? So I could say that angle A is congruent to, put a little congruent sign, what? Angle B. All right? That's what I know about that situation right there. Yes, ma'am. Good. Give me your book. I wish you guys would go before you come in here. It's just because it's not just you guys, it's every single class. I get 2, 3, 4, 5 people asking to go to the bathroom all the time. And just, that's why I get frustrated, right where you're going and stuff.
You probably just think as an actor, you should best go on. Oh, you did?
I know sometimes after lunch you don't feel like you got to go, but you know, if you haven't gone since the morning, then go. My dad always said this. Listen to this statement. This is profound. Make sure I say it right. Now I got to think out. He said, I had it. Oh. Go when you can, not when you have to. You hear that?
Yeah. Go
when you can, not when you have to. That always stuck with me. He told me that when I was a little kid, and I always remember that. So if you have a situation like, I don't really know if I have to go, but I know I got 3 hours left, right? I should probably go now if I got a time, like after lunch or during lunch, right? During lunch is the perfect time to go to the bathroom. All right, enough said. Let's talk about one more thing. Oh, no, we got a little bit more to do. In my other CP class, I ended at this next word, but I think we got time.
Is the bell ring? No, because
I think we have time. Yeah, this is
20
15.
minutes?
Yeah, you got 18 minutes. We got plenty of time. We should be able to finish this lesson today. All right, and then you'll be ahead of the other CP class. How about that? This one is called adjacent angles. You ever heard that word adjacent? Somebody tell me in general, not in geometry language, but just in everyday language. What's an adjacent? What does it mean to be adjacent to something? Okay, kind of, side to side. Or anybody else? What do you think? Forget the angles, just in general English words. Adjacent. So if I lived adjacent to you, what does that mean? Where do I live? Well, it could be across, but right next to you. Okay, that's what it means. So if somebody is adjacent to somebody, they're usually right next to them. Okay, so that's what adjacent means. Everybody got that? You'll hear older people say that word. Young people don't hardly ever say adjacent. But now you can start using that word in everyday language. So let's bring this into geometry. All right, so draw this and like that. All right, so I got 3 angles. We've seen this picture before. Oops, it's M. So that's M. This is N. Finally, I stopped using A, B, and C.
Dude, A, B, and C on top.
And P. All right, there we go. So just with that definition, just with that normal definition, I haven't really given you the definition for the geometry part of this, but just knowing that adjacent means next to something, I'll tell you what, I'm going to name some angles in here just to make it a little easier so we don't have all this alphabet soup running around. So we'll call this one angle 1, we'll call this angle 2, and this arc right here is just representing the big angle, and we'll just call that angle 3. That'd be easier than saying angle MNK and MNP and all that kind of stuff, right? So let's just talk in terms of angles 1, 2, and 3. So which ones, just looking at it, and you know that adjacent means next to, right? It means to be next to something. Which angles do you think are the adjacent angles, Lily? Give me numbers. If I say M and K is not an angle. Remember that, okay? M is a point, K is a point. It's not an angle. 1 and 2, right. You'd probably think that 1 and 2 would be adjacent angles because they're right next to each other. What about 1 and 3?
No.
Why not? Because they're what? Because angle 1's included in angle 3. That would be one way to say it, right? Because, so like if my house was inside of your house, okay, then they wouldn't really be adjacent to each other, would they? All right, even though they maybe share a wall or something like that, okay? Wouldn't be adjacent to it, wouldn't be next to it, be in it, wouldn't it? All right, so that's one way to think of it. Here's the geometry thing. So there's 2 things you need to know about adjacent angles. In order for 2 angles to be adjacent angles, they have to have a common side. All right, so the angles have to have a common side. So that's one thing. There's 2 things that have to be true about it, okay? One thing is they have to have a common side. So look at angle 1 and 2. You guys said that angle 1 and 2 are adjacent to each other. Do they have a common side?
Yeah.
And what is it?
K.
Again, you're giving me... K is a point. What's a side of an angle? A side of an angle is always a what? We talked about it earlier today. Say it. A ray. That's right. Okay, the side of an angle, listen to me. Before you speak, think. Just think for a second before you raise your hand. You don't have to be the first one with your hand up. Okay, just think first. Everybody think. What is the side of an angle? It's a what? It's a ray. So if I asked you, what is the common side? A ray, right? It's got to be a ray. What is the common side with angles 1 and 2? Which one is shared by angles 1 and 2? Anai. Say it a little louder. NK, okay. You're right. Ray NK is shared by both of these angles. Look at angle 1. What are the two rays that make up angle 1? NM and ray NK. What rays make up angle 2?
NP.
It's a P. NP and ray NK. NK is shared by both of them, right? So the common side, let's just write it down. The common side is, it's supposed to be an N. It's kind of weird looking. All right? NK. So it does have a common side, but something else has to be true. Okay, and this is the one that's a little bit weird. The common side's pretty easy to see, but the no common, so this one is no. So it's no common interior points. So the two angles do not have any common interior points. What in the world does that mean? I'll show you. Yeah,
It's N.
NK. I said it. I said it looks weird, but it's an N. Right here. It's NK with a line over top of it.
Oh, it's a line.
Right here. It's a ray. You're right. I lied.
Aha, liars.
Didn't really lie, but you get the idea. The common side would be NK. Thank you. Appreciate that because I didn't want to mess up on that. So, yeah, it's ray NK. It's a weird N, but I didn't want to write it over again. So what does it mean to have no common interior points? Well, let's put a point in one of the angles. Let's put a point in angle 1 or inside of angle 2 in the interior. We talked about the other day, right? Interior angles. So what if I put a point right there? Now, where is this? It's in the interior of what angle? 1 or 2?
1.
It's 1. Is it in the interior of angle 2? No. What if I put a point right there? What if I put a point right here? What if I put a point right here? Right here. Is there any place where I could put a point that it's in both angle 1 and angle 2 at the same time?
On ray NK.
Then is it in the interior?
Oh, no.
Then it's not on the interior. Then it's on the angle, right? Interior, it's got to be all these. So, does it have any common interior points?
No.
Angle 1 and 2? No. So, does it fulfill both of these things right here? Absolutely. So, these two angles, angles 1 and 2, are adjacent angles. Okay? And there's going to be a couple times, not a whole lot. You don't really see this adjacent angles a whole lot. But there are a couple times, I can think off the top of my head, there's a couple, 3 times where we are going to talk about adjacent angles. So we're going to see something completely different, and we're going to talk about, the adjacent angles. And you're like, oh yeah, I remember talking about this at some point. All right, so you need to know what the adjacent angles are. Akira, do you have a question? Right, they can never have a common interior point if they're going to be adjacent angles. I doubt it. It's just kind of the definition of adjacent angles, just so you know. It's like a little test, right? It's a 2-part test to see if they're adjacent angles or not.
Is there like a symbol for it?
No, they would just say, usually it's probably going to be like in a theorem or an apostille or something. They'll say, blah, 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 the adjacent angles, blah, blah, blah. And you just have to know what adjacent angles. So this is basically just definition, is all this is, just so you know what the word means. Remember we said that 1 and 3 are probably not adjacent angles? Remember I said my house inside of somebody else's house isn't really adjacent? Well, let's see if it fits this little criteria right here. Okay, so if I put a point in here, first of all, let's look at 1 and 3, right? We talked about 1 and 3 before. Does angle 1 and angle 3 have a common side? Does angle 1 and 3 have a common side?
Yeah.
What's the common side? It's a ray. Ray NM. Very good. Okay, so ray NM is part of angle 1, and ray NM is also part of angle 3. Everybody see that?
Yeah.
Okay? So if I put a point right here, where is that point? It's in angle 1, but it's what? It's also in the interior of angle 3. So you do have a common interior point, don't you? All right? Anywhere I put a point in angle 1, it's also going to be in angle 3. So are they adjacent angles? No, they're not. Right? I mean, that was a long way to go. I could have just said, oh, they're angles that are next to each other. See that? They're adjacent. Boom, you're done. All right? But they do have to fit this criteria. And sometimes you might see some things. I didn't do this with the other class, but I'll do it with you guys. A lot of people might think this is a weird situation, one you haven't seen before. What if we, oops, I don't want to start there. What if we did this? That is weird, isn't it? So it's not just one angle, though, is it? All right. So you got an angle here, you got an angle here. Okay. We'll call it 1 and 2 again. Look at 1 and 2. Are they adjacent angles?
Yes.
Well, let's go through the thing. Do they have a common side?
Yes.
What's the common side? Just describe it to me.
The
Is it the bottom one, the left one, or the right one?
right one. The right one. Oh, the bottom one. Yeah.
The bottom one? Okay, it's the same for angle 1 and 2?
Yeah.
Well, look at this ray right here. We'll just call it ray 1. We don't really call it that, but just for the sake of argument. Okay, this first ray right here. That ray, is this ray exactly the same as this ray?
Oh, no.
It's not, is it? Because this has a bunch of extra stuff that this ray doesn't have. Agreed?
Yeah.
I mean, they share. I mean, this right here is kind of shared by both of them, but the whole ray is not. So does it have a common side? No. So this would not be adjacent angles. Okay? That's the only other thing I could think of that they might ask you about as far as, if they're adjacent or not adjacent. That's pretty much it.
Wait, how is the right angle not the common side?
This one right here?
Yeah.
What, this?
Yeah, that one. No, not that one.
Well,
not that one. What's it called?
this one?
Yeah.
Well, that's not even close to part of angle 1. Well, it's close because this little bit, right, is common, right? But this is not common, right? Even though it intersects, it doesn't mean it's a common side. The angle 1 does not share this part right here. It doesn't share this ray whatsoever, right? So you can't say that that's adjacent. We good?
Yeah.
Okay. Let's see. Got a little bit more. This is going to help you out on some of the homework because you got quite a few homework problems that do what we're going to do right now. Would I say 50? Is that one we're over? Get rid of this now. All right, let's do another one. We got this. We got this. Kind of looks like what we just drew. And then you got one more. Got one like this. All right, and we'll do the same thing. We're going to number them the same way. That's 1, that's 2. This whole thing right there is 3. So we have a thing called the angle addition postulate. Write it down. Angle addition postulate. Remember the difference between a postulate and a theorem? Postulate is just accepted as fact. Okay, we can't really prove it. We just accept it as fact. So, basically, let's do this. I'll just show it to you. If I took angle 1 and I added angle 2 to it, okay, this is probably the first time we talked about adding angles together. But if I took whatever the measure of angle 1 was, and if I took the measure of what angle 2 is, what do you think that's going to equal?
Angle 3.
What angle 3 is. It's the whole entire thing, right? Does everybody see that? So, for instance, if I actually put some numbers in here, that's a real skinny angle. What do you think? Give me a good number for that. Like 20 degrees? And let's say this is, 40
80.
degrees. Let's say it's way shorter than 80. Okay? So let's say that's 40 degrees right there. Everybody watching? So the angle addition postulate allows us to say that the whole entire angle 3 is going to be what? 60 degrees, okay? So again, you would just go, this is 40, this is 20, and then 40 and 20 is 60. These are degrees, okay? That's basically what it says. Now, let's do an example with that. We got about 4 minutes, okay? So let me get rid of this. Everybody write that down? Okay. So let's put this angle over here. Let's go like this. Let's go like this. And let's stick one right in the middle. Something like that. All right, here's our picture. This is an example, so this is kind of stuff you're going to do, some of the stuff that you're going to do on your homework, not all of it. All right?
Is this still 1.5?
Yeah, still 1.5. It's the very last thing in 1.5. So here's the example. Let me put angle 1 here. Let's put an angle 2 right there. Let's make this A. Let's make this B, C, and D. All right, so there's the picture they give you. And they tell you that angle 1, so they tell you that angle 1 is equal to angle 2. All right? So those two are equal. They may not look at, this one looks a little wider, don't you think, than that one right there?
Yeah.
But they tell you they're equal, so we just go by what they tell you. All right? So here's the question. It says find angle 2 if angle BAD, I'm sorry, not if, sorry, and BAD. We're going to find both of those. If angle 1 is 55 degrees. Okay? The first part of this is super easy, because what did they tell you? They tell you 1 and 2 are exactly the same, right? All right, so what would angle 2 be without doing any math whatsoever? Yeah, it'd be 55 degrees, right? So angle 2 would be 55 degrees. We don't even have to show any work on that, right? Because we just know they're equal to each other. So if 1 is 55, then 2 is going to be 55. Here's when we have to think about it a little bit, and it's really not that hard if you understand that addition, angle addition postulate. We also got to find angle BAD. Well, where's BAD?
Everything.
It's from here to here to here. It's this whole entire thing.
It's angle 1 and 2. Right?
So what do we do? It's angle 1 and 2. So what do we do with those?
Add 55 and 55.
That's it. So angle 1 plus angle 2, right, is what? 55 plus 55, which is 110. And that's equal to angle, what is it? BAD, right? It's that bad angle. That's a very simplified version of what you're going to do. But on the homeworks, they're going to, don't write this down. I'm just making stuff off the top of my head. They're going to give you this one as like 3x minus 2, and this is, I don't know, minus 2x plus 3 or something like that, okay? So what would you do? Well, I'm sorry. Yeah, what would you, nah, it's not going to be exactly like it. It's going to be something where they give you variables, okay? And they're not always going to say that 1 and 2 are equal to each other. They might tell you that angle BAD is equal to, I don't know, like 130 degrees or something like that. What would you do? What would you do to set this up? So angle BAD is 130 degrees. Angle 1 is 3x minus 2. Angle 2 is negative 2x plus 3. What would you do? How would you set it up? Now, this probably won't come out nice. All right, I just made these numbers off the top of my head. Naya?
I would do U or basically minus 2x.
Right. Yes, put the plus, that's fine. Plus negative 2x plus 3 equals what? 130. Okay? Everybody see that?
Yeah.
So basically, I just did what the addition postulate said. Just add this one and this one, set it equal to the whole thing, which in this case is 130. That's the kind of stuff that you're going to do. Okay? You solve for x, right? You do some algebra. Is this the first time we did algebra in here?
No.
I think we did it the other day. Yesterday, did we? Okay. So we do some algebra. Shh, listen. We do some algebra, solve for x. Does that mean that's our answer? No, we take x and then we do what? Substitute it or plug it back in for that. Okay? So you should have your homework from the lesson plan I gave you on Monday. But it's, I'll put it up here. It's section 1.5. And it's pages 27 to 29. And it's broken up into 3 different parts here. 21 to 28. You guys don't need to write this down, all the ones that are talking. It's on your lesson plan. Do you have your lesson plan? I have one up here. Okay, that's it right there. 1 to 14, 21 to 28, 34 to 45. It's also on RenWeb. Okay, I put all your lesson plans up on RenWeb as well. Okay, that's enough.